Well, hello everyone. Now, about a year ago, I started a project to output pulse width modulation from a computer's serial port. Now, I made some pretty good progress, and we incorporated the use of a keyboard to control the pulse width. But there were still a few things that we left unfinished. I didn't properly program the serial port's controller chip, so we couldn't control the baud rate very well. And I didn't have any way of displaying any kind of information. Well, today I want to show you how I've addressed these two issues. Alright, so I've made two new versions of the program. One is for computers that run DOS, and the other one is for computers that don't have an operating system. You just put the floppy directly into the computer and it will boot right off the floppy. So I'm going to go ahead and start this computer up, and I'm going to show you how it works. Okay, so it's just booted up. Alright, so this is the program running. Now, as you can see, we have a nice message that I've written there, so it tells you a bunch of different things that's happening, however the program's currently configured. And note here, 16-bit, that means this is the version that doesn't run on DOS or any other operating system. This is running directly on the computer's hardware. Now, just as the message says, you use keys 1 to 9 to adjust the pulse width. Now, every time you do change the pulse width, let me show you. I'll press number 1. It shows you that 90% duty cycle has been selected, and through any of the keys it shows you the different duty cycles. So if I press 2, it shows 80% duty cycle selected, and so on until it gets down to, if you press 9, it gets down to 10, because that's the lowest duty cycle that you can select. Okay, so I was able to actually program it's called a universal asynchronous receiver transmitter. That's the chip that controls the serial port. I was able to program that, and now it's consistent. The baud rate's the same between both the DOS version and the version that runs directly on the computer here. So the output is now at a much higher switching frequency. It's a little bit higher than 20 kilohertz, but as you can see, it still does the same thing. That part hasn't changed. Keys 1 through 9 still adjust the pulse width. You just get a nice readout now, and the frequency is consistent. Alright, so now I want to show you the DOS version of the program. It's pretty much the same thing, but there are just a couple minor differences here. As you can see, the message is the same, except for, now you can see this one is for DOS. It's not for directly booting on the computer. The baud rate and everything is still the same. The operation is still exactly the same, but now you'll see it says press escape to exit to DOS. So with this version, you can press escape and it will take you right back to DOS. So you don't have to restart the computer with this one, obviously. But like I said, the operation is still the same. You press the different keys and it will tell you whatever duty cycle that you are currently requesting. Alright guys, so unless somebody actually asks me to, I'm not going to review all of the code here, because now with the display it shows what pulse width you've selected. There is a lot more code to go over, but at its core it's still basically the same. So one more little piece of information I should tell you guys about before we end this video. The boot version of the pulse width modulator has some extra code in it that wasn't written by me. Now you can put a program onto the first 512 bytes of a floppy. Now that's where the master boot record is. Now that part will boot up the computer, but if your program is bigger than 512 bytes, then you need to write a program that fits in that master boot record and then jumps out and starts executing your program, which is in the larger part of the floppy. Now this is just his internet handle. I don't know what his actual name is, but Mike at brokenthorn.com, he has a tutorial that will show you how to write a bootloader and some other very interesting things, how to write different parts of operating systems. It's all pretty cool if you're into computers and programming, so credit to him. I'm using sections and basically the majority of his bootloader, just modified a little bit. So I thank you guys for watching, and if you have any questions, go ahead and comment and message and I'll try to get back to you guys. Thanks for watching.